This is dividing decimals by decimals. We already did a video about dividing decimals by whole numbers, and we saw that was very straightforward. Dividing decimals by decimals is something that people get a little bit anxious about sometimes. I'm not quite sure why. Let's look at it. Let's start off with some whole numbers again, and then we'll use this to explain why the method I'm going to show you actually works. Let's take the sum 90 divided by 30. What does it mean? That means how many times does 30 go into 90? And I reckon you probably know that the answer to that is 3, right? Three threes make 9, and so therefore 3 30s, 30 and 30 is 60, 60 and 30 makes 90, 3 30s and 90. You can make that sum a little bit easier for yourself, and some of you might have actually thought of doing that by doing something I actually just sort of hinted at myself when I was describing my answer. You could actually make each of these numbers 10 times smaller and still get the same answer, because 9 divided by 3, of course, is also 3. How many 3's go into 9? Of course, it's 3. So, in actual fact, what we see here is if we adjust the two numbers in a division sum by the same factor or multiple, in this case we divided them both by 10, then if we divide the two new numbers that we get, then the answer will be the same as the original answer. So long as you adjust your two numbers in your division sum by the same factor or multiple, then the answer you get using the new numbers will be the same as the answer you would have got with your original sum. I'll show you another example. If we think of one, let's have a look at this here. 280 divided by 40. You might not know how many 40s make 280. You may never have learnt your 40 times table, curse you. But I bet you learnt your 4 times table at least a little bit, didn't you? So in actual fact, if we make these numbers 10 times smaller, I could say knock a 0 off, couldn't I? But that's not very grown up. If we make these numbers 10 times smaller, it will make our life much easier, won't it? Because 40 divided by 10 is 4, and 280 divided by 10 is 28. And we know that 28 divided by 4 is 7, can't we? Let's count in 40s just to prove that I'm right. Two 40s, 40 and 40 is 80. 80 add another 40 makes 120. 120 plus a fourth 40 makes 160. 160 plus another 40 makes 200. That's 5 40s, so 5 40s are 200. And another 40 is 240, and the seventh one makes 280. So I'm right, aren't I? 7 40s are 280. So you can see here that if we adjust just two numbers in our sum by the same amount, the answer we get is the same. Just to prove it doesn't have to be dividing by 10, let's just halve these numbers. 28 and 4. What's half of 28? That's right, well done. It's 14. And what's half of 4? Correct again. Well done, it's 2. What's 14 divided by 2? How many 2's go into 14? Yay, look. Still the same answer. So, what we learn from this is that we can adjust the numbers in a division sum any way we like, as long as we do the same thing to both the numbers. And as long as we do the same thing to both the numbers, then the answer we get with our new numbers will be the same as the answer we would have got with our original answers. And that comes in rather handy when we have to divide numbers by a decimal. Let's take a sum like this. 38.01 divided by 0.3. Well, we've looked at setting out sums like this, haven't we, in the past, and it's a great way of dividing, but it's a bit trickier in this situation if we're trying to divide by 0.3, because we end up saying how many lots of 0.3 go into 3, and I reckon actually that you could probably get, how many I reckon I get 10 lots in there, can't I? Because 10 times 0.3 is 3, isn't it? And straight away I can see something's up here, can't I? Because I've only got space for one digit, and I'm wanting to put 2 digits in here. How many lots of 0.3 go into 8? Oh dear, there'll be 20 something, won't it? And you can see where you're going to get a rather messy answer here, and in fact an answer that makes no sense, more than fact. So we can see that dividing by a decimal is actually not entirely straightforward. And so to make our life easier, don't you think it would be better if we could turn our 0.3 into a whole number? It would, wouldn't it? And do you know, can you think of a way of turning 0.3 into a whole number? Of course you can, because you're not as stupid as you thought you were, are you? You can times 0.3 by 10, and bingo, it turns into 3 magically, and we know we can divide numbers by 3, because we're quite clever, really. But then that's where what we just talked about comes in. If we're going to times this number on the right by 3 to make it into a whole number, then we have to times the other number by 10 as well. Whether it's a whole number already or not doesn't matter. So we have to times 38.01 by 10 as well, and that gives us 38, that's what it gives us the decimal point with one space to the right, it gives us 380.1. So our new sum, having times both numbers by the same multiple, both numbers by 10, is 380.1 divided by 3. And if we now go ahead and do this calculation, 380.1 divided by 3, we will see that the answer we get here is the answer we would have got to the original sum. So, 3's divided by 3. How many 3's go into 3? 1. How many 3's go into 8? 2 remainder 2. How many 3's go into 20? 6 remainder 2. Don't forget decimal point. And how many 3's go into 21? 7. We get an answer of 126.7. It seems a bit odd since we started with a number of 38.01. The answer we've got here is bigger than the number we started with. We started with that, we've ended up with that. Does that make sense? Well, it doesn't until you realise the number we're dividing by is less than 1. And we're saying how many lots of 0.3 go into 38? And of course, you can get more than one lot of 0.3 into 1, can't you? So for every 1 there is in 38, we're going to get about 3 or so 0.3s in, aren't we? So our answer should be about 3 times bigger than the number we started with, which it is, isn't it? Because of course 38 is 40, 40 times 3 is 120. We're about right there, aren't we? So there we go. So we times both those numbers by 10 to make the divisor. That's the number we're dividing by. This one here. We needed to make that a whole number. This number here that we're, the dividend I think it's called, that we are dividing doesn't need to be whole. As we looked at in the previous video, you can very easily divide decimals by whole numbers, and just to make sure the decimal points included in your answer in the same place. That's easy peasy. But this number here, the divisor, does want to be whole. And to do that here, we times it by 10. Let's do it again with a number, another number. How about 63, 600 and another 3, have you noticed? 6,324. Can't do that, sorry. 2 for 9,324 divided by 0.06. Okay, again, we're faced with the same problem, same situation. We don't really want to divide by a whole number, by decimal. We want to make this a whole number. How can we make 0.06 a whole number? Well, if we move the decimal point 2 spaces to the right, that will make it whole, won't it? And we can do that by timesing it by, not 10, by 100. We want to move it 2 spaces to the right, let's times the number by 100. If we do that to the divisor, we have to do the same thing to the other number, keep the numbers in the same proportion, so that our answer at the end is the same as the answer we would have got originally. So 9,324 times 100 for the decimal place, the decimal point with 1, 2 places to the right, put a couple of zeros in there to hold it in place, and that gives us that number there. So we're now going to divide, what's that, 932,400 by 6. Much easier than it sounds. 9, 3, 2, 4, 1 bit at a time. How do you eat an elephant? 1 mouth at a time. How many 6's go into 9? 1 remainder 3. How many 6's go into 33? 5 6's are 30, so it's 5 remainder 3. How many 6's go into 32? Well, that'll be 5 remainder 2 then, won't it? How many 6's go into 24? 4 6's are 24, aren't they? And 0 divided by 6 is 0, and so is 0 divided by 6. So it gives us an answer of 155,400. Again, the answer is bigger than the number we started with, but again, that makes sense because we're dividing by 600ths. We're saying how many lots of 600ths go into 9,324. The answer is loads. Okay, but, to be honest, that's it. That's dividing by decimals. You just have to make sure that you make your divisor, the number you're dividing by, into a whole number, and that's fine. And then the rest just deals with itself. 6.5275. Wow, I managed to do a number without freezing. Divide that by 0.0005. Okay, I don't want to divide by a decimal because it's hard. So I want to make my life easy. So I want to divide by a whole number. So I need to move my decimal point here, move it out the way 1, 2, 3 spaces to the right. That's times in not by 10, not by 100, but by 1,000, isn't it? So times by 1,000. And if I times the number on the right by 1,000, I'll do the same thing over here. Keep my numbers in proportion to make sure I get the same answer at the end there would have got the original numbers. 1, 2, 3 spaces to the right, gives me that. 6, 5, 2, 7, 5 divided by, and the rest. It's like shelling peas, isn't it? It's really like taking candy from a baby. Shouldn't really be much easier. As long as you concentrate and make sure you're careful with your arithmetic. You know you can make mistakes, don't you? Especially if you're a boy watching this. How many 5s go to 6? 1 remainder 1. How many 5s go to 15? 3 with no remainder. How many 5s go to 2? You're right, none. And the whole of that 2 is left over still, so we'll carry that 2 across to the 5. Across to the 7. How many 5s go to 27? 5 remainder 2. Don't forget your decimal point. And how many 5s go to 25? 5 do. I'm going to repeat something I said earlier. This number here, the number you're dividing, does not need to be a whole number. As you can see here, dividing a decimal is easy as long as you're dividing it by a whole number here. So it's this number here. I'm repeating this because it's important. Some of you get in a muddle with it, don't you? This number here, the divisor, the number we're dividing by, needs to be a whole number to make our life easy. And if we adjust this divisor by something to make it into a whole number, then we have to make sure that we do the same thing to the other number. The other number might already be a whole number, in which case we just tack a few zeros on. If it's not a whole number, then we move the decimal point the right number of spaces. That might make it into a whole number, or, as is the case here, it might not make it into a whole number. That is not a problem. We can divide this number, this decimal, by a whole number really easily, as long as we remember the decimal point. It's just you need to make sure, I'm saying it over and over again, because I want you to understand, A, that this is the important bit, and B, how very, very easy it is. Just make the number you're dividing by a whole number. Whatever you do to that number to make it a whole number, do the same thing to the other number, and divide away, and the answer you get here does not need any further adjustments. That is your final answer, as long as you did the same thing to both numbers at the start, which we did 3 times in both lines. That is dividing decimals by decimals, dividing whole numbers by decimals. Turn the number you're dividing by into a whole number. Good luck.